Welcome. Today we're going to talk about periodic table trends that are extremely important in general chemistry. And the most important thing to remember that rather than just memorizing these trends and kind of just by hearting them in your head, you should understand exactly why these trends are the way they are. So let's get right into it. The first trend we're going to discuss is atomic radius. This is the most important trend you will need to know because once you know this one, everything else you don't have to memorize. You just base it off of your understanding of this one. So what is atomic radius? Well, atomic radius is exactly what it sounds like. So say we have a nucleus over here, and then surrounding the nucleus we have the various energy levels. And on the outer energy level we have our valence electrons. The atomic radius is the distance from the center of the nucleus to that outermost electron. On the periodic table, atomic radius will always decrease from left to right. So you have a decrease in atomic radius going from left to right, and when going from top to bottom, you have an increase in atomic radius. That's because as you go lower and lower in the periodic table, more and more energy levels will get added. And that's what's going to increase the distance between the valence electrons and the center of the nucleus, which is exactly what the atomic radius is. Moving on to the next trend, we're going to talk about effective nuclear charge. So, another way that we refer to effective nuclear charge is by calling it Zeff. That's kind of the shorthand. What is Zeff? Zeff is the net positive charge experienced by the outermost electrons. In other words, we have our nucleus over here. We have our outermost electrons over here. It's how much the nucleus is pulling these electrons and how much of a pull these electrons experience, which is the net positive charge. So if we recall the trend for the atomic radius, we know that it decreases from left to right. So that means from left to right, the distance between these valence electrons and this nucleus is decreasing. And as these valence electrons approach closer and closer to the nucleus, they're going to be more attracted to the nucleus, and their net positive charge will increase. In other words, the Zeff will increase. So going from left to right on the periodic table, Zeff will have an increase. Going down on the periodic table, we know that atomic radius is increasing, which means that the distance from the nucleus to the valence electrons is also increasing, which means that the positive charge and pull that is experienced by those electrons is decreasing. Now let's move on to the next trend we need to know. Ionization energy. So what is ionization energy? It's the amount of energy required to remove an electron. Energy required to remove an electron. So we know that atomic radius is decreasing from left to right, as we're going to keep reiterating and reiterating because it's the most important thing we need to know. We know atomic radius is decreasing from left to right, which we said that means the Zeff is increasing. And if the Zeff is increasing, that means the ionization energy must decrease. Why? Because as the electrons are feeling more and more of a pull towards the nucleus, it's clearly going to become harder, much harder, to remove those electrons. So it's going to increase the ionization energy, not decrease. I apologize for that error. So it's going to increase the ionization energy. So going from left to right, the ionization energy will increase, meaning more energy has to be put forth in order to remove an electron. Going from top to bottom, we're going to see a decrease because we know, as we've reiterated, that as you go from top to bottom down a group on the periodic table, the pull that the electrons experience to the nucleus is smaller because they're further away, which means that the amount of energy needed to require one of those electrons will decrease. The next trend we're going to go over is electronegativity. Electronegativity is the tendency of an atom to attract a bonding pair of electrons, and it's positively related to ionization energy. Why? Because if it's easier to remove an electron, then the attraction between the nucleus and the electron must be lower. So the trends that we're going to see for electronegativity is going to be the same as ionization energy. So from left to right is going to increase, and from top to bottom it's going to decrease. And finally, we're going to go over the trend for electron affinity. And this is extremely similar to all the other terms we went over. It's how much the nucleus wants to pull in those electrons. And a good way to remember this is to just break it down. Affinity means love for something or attraction for something. And we know an electron is an electron. So electron affinity is how much love and attraction a nucleus feels towards the electrons. In other words, it's how much the nucleus wants to pull in those electrons. And this is going to be, once again, the same trends as electronegativity. It's going to increase from left to right. Why? Because the atomic radius is decreasing, meaning the distance between the nucleus and the electrons is also decreasing, meaning that's going to be much, much easier for the nucleus to want to pull in those electrons, increasing its electron affinity. And going down, it's going to decrease once again because the atomic radius is increasing, which pulls those electrons further apart from the nucleus, which decreases the electron affinity. So there you have it. Those are the trends. Thank you so much.